Thank you everyone for making the time today. This is START8 and I'll be presenting on rapidly building and deploying applications using AWS App Runner. I am Bikram Bora. I'm a solutions architect based in Melbourne, Australia. So what will we go through in the session today? We'll be going through what App Runner is, what are the types of applications that are best suited to run on AWS App Runner, how it simplifies your containerized application stack, what are its features around networking, storage, and scaling that help alleviate some of the undifferentiated heavy lifting for you. We will go through a demo of looking at App Runner in action. Finally, we'll look at some additional features and the pricing model that we have offered to customers. So let's get started. What is AWS App Runner? AWS App Runner is a fully managed service that makes it easy for developers to quickly deploy containerized web applications and APIs at scale with no prior infrastructure experience required. Start with your source code or container image. App Runner builds and deploys the web application automatically, load balances it, there's traffic encryption, and it scales it to meet your demand. It makes it easy for your services to communicate with other AWS services and applications that run in a private Amazon VPC. With App Runner, rather than thinking about servers and scaling, you have more time to focus on your applications. What this means is your team can instead focus on building out your applications and features and getting those features out the door quicker. As we mentioned, AWS App Runner is best suited for web applications and front-end or back-end API servers. Basically anything that is a HTTP request and reply-based service. The application must be written as a long-running web application and can service many requests during its lifetime, even simultaneously. It is not like a Lambda function where one invocation only handles a single request and exits. The application must be stateless. Request processing should not depend on any local state on disk. You can choose to store state in other external databases or data stores. And there should be little to no background processing. And by background processing, I mean any processing that happens offline outside the context of a request should be avoided. Let's look at a typical containerized application stack that is running in most environments today. So firstly, we have the physical server that then has a hypervisor that's running on top of it. If you have a virtual machine on top, if you're running on AWS, that's typically an AWS EC2 instance that has a Windows, Linux, or guest operating system on top of it. And then you have a container orchestration agent. So if you're using Elastic Container Service ECS, in that case, you have the ECS agent running on top of that application. And then on top of that, you have the containers deployed. Then in terms of scaling, you can use auto-scaling to replicate the host based on whatever is your required demand. And the allocation of the containers onto different hosts is done by a typical container orchestrator like Amazon Elastic Container Service or Elastic Kubernetes Service. This is then fronted by a load balancer, an application or network load balancer. And typically alongside this, it is some sort of a CI/CD pipeline or tooling that deploys those built container images onto the running instance. This is quite a lot of complexity, as you can see, that is simply to run a few containers. This can take weeks, days, or even months for teams to run, configure, and set up to run a production-ready service. All of that time spent building the stack could instead be used to build features for your application. So instead, let's look at what the new picture is once AWS App Runner is being used. So going back to the stack earlier, when we initially released AWS EC2, that took care of the initial hypervisor layer for you and your guest operating system. Then with Elastic Container Service, we absorbed the responsibility of the container orchestrator. Going one step beyond that, when we launched AWS Fargate, that meant you no longer cared about hosts either. All you had to do was give us your containers and you manage the containers at a task level. Now with AWS App Runner, we're also taking away the responsibility of load balancing and deployment for you, which means all you have to do is focus on building your app and packaging it a container, and then we'll build it, run it, deploy it, scale it, and load balance it for you. So looking at how simple this has now become for teams to do a production app today. Now let's look at what is packaged inside that app. This is a running instance of your container, which we call an application instance. It has two dimensions of performance. One is memory and CPU, and it's coupled as well. So for one vCPU, you get 2, 3, and 4 gig variants, and for 2 vCPUs, you get a 4 gig variant. It is priced according to these two dimensions as well. Next, let's look at network ingress and egress of the application instance. There are two modes in how networking works in AWS App Runner. One is the public internet mode, and one is the VPC mode for network ingress, which you get a secure URL that we will publish and manage for you on your behalf. We will also manage the TLS certificates for this URL. For traffic egress, any traffic that the application instance is reaching out for, you have two modes. One is the internet access mode. So in this mode, you can reach out to any public endpoint, that being an AWS endpoint or other parties, or for any third-party service. On the second configuration is where you add a VPC. So instead of allowing it to access any internet resource, you can limit it to just the resources sitting within your AWS VPC. Then if you wanted to call an AWS API, you would then use a service called AWS Private Link, which allows you to access AWS resources securely without reaching out to the public internet. Next, let's look at scaling. Let's now look at auto-scaling now, and what are the levers and controls you have in place to manage it. So in AWS App Runner, the parameter that you would use to configure your auto-scaling is called concurrency. What does that mean? So if you have a running container and that you've tested on your local machine or in the cloud, and you've seen that it can service about 10 to 15 requests concurrently, having done some benchmarking locally and in the cloud, you can tell us how many concurrent requests it can handle. Then, when your incoming requests are coming in, we scale out and distribute the requests for you. Let's say in this request, 30 requests are already fulfilled. Once we start to get beyond that said number of requests, we automatically provision more application instances for you. This is very similar to EC2 autoscaling. We also configure a lower bound, a desired count, and an upper count for you, so you have some degree of control of what is the lowest and the highest threshold you want to configure, based on how much traffic you're getting. Next, let's look at the deployment experience. We have made the deployments via App Runner really easy for application developers. There's two variants that you can deploy to AWS App Runner. One is directly from source code. You connect your GitHub account and point us to your repo, give us your Docker build file, and you're ready to go. The other is a pre-built Docker image that you publish to an ECR repository, and we pick it from there. You create a connection to your GitHub or create an IAM rule that gives us permission to access that image. Then it's a simple API call where you can configure build and runtime parameters, the CPU and memory you want your container instance to have, any health checks on your load balancer, and the concurrency for auto-scaling configuration. The deployment is either automatic or manual based on how much control you want us to have. This can be automated based on an image that you publish, or if your source is updated, we automatically kick off a deployment for you. If you wanted more control, we also have manual deployment triggers for you. Once this service API call has been executed, what you get is a secure HTTPS URL, which your clients can connect to immediately. It's as simple as that. As you saw, the only input that you're really giving us is your source code and your container image, and the output that we're giving you back is a managed load balanced secure HTTPS URL. Now let's look at this in action. So we go into the create a service option. We have two options for our repository type. We can either pick a container registry or we can pick a source code repository, which is where you'd connect to GitHub. If you had picked container registry, you have options of a private ECR repo or a public ECR repo if your image was public. And then you'd have to give us the URI of your Docker image and some IAM access so we can access said image. For this demo, let's pick on source code repository. Now I'd have to create a connection to my GitHub. I have already created a connection to my GitHub repo. That's the one here. If I hadn't, then you can go add new. It'll ask for your connections to your GitHub organization, and then you're good to go. If you had used GitHub organization, you may have to install the AWS connector for GitHub in your account, after which your connection will appear here. For repository, I will pick the Hello App Runner repository. So what is this repo that I just typed in here? Let's go into my GitHub and take a peek. Here we are in GitHub. using the Hello App Runner repository. This is a repository that AWS has published for you that makes it easy for you to get started with AWS App Runner. All of the requirements are listed in here in the requirements.txt file, and the configuration for App Runner is all in code as well, which is in the apprunner.yaml file. The reason this is very cool is because you can commit your configuration for the service into source as well, which means every time there's an update, it's all tracked via your source control system. Going back into our service, let's pick on the branch that we want to deploy. So in my case, I want to pick the main branch. I can select manual deployment, in which case I have some sort of an approval process via the console or the CLI that I need to approve for deployment to go through. But I'm happy to click on automatic deployment. This means that the App Runner service will monitor my branch for a new commit or a new push, or will monitor my Docker image repo for a new image that's available. As soon as either of those criteria are met, it'll then trigger a deployment immediately. Let's click on Next. On this screen, I can choose my runtime for the service or select a Docker image. If I was to select a managed runtime, I've got the Amazon Corretto Java environments, Node.js environments, or Python environments. I can configure the port that the container is running the service on, and that's the load balancer we'll be using to connect to the container on. However, all of these settings I can do using a configuration file. This is the apprunner.yaml file that we looked at earlier. Let's have a look in detail of what is inside that file. Here we are in the apprunner.yaml file. Inside this file, I have the build instructions for my project and then the run instructions. So this will install the dependencies, package the application, and run my server for me. In my case, it's a Python-based server. And I've selected the port, which is the port 8000, which is where my application is running. Let's go back into App Runner and click on Next. I have to give my service a name, so let's name it my Summit service. I have to pick the CPU and memory that I want for the service. We'll cover the pricing dimensions later on in the presentation, but for now, these are the primary pricing dimensions that you have to be aware of for benchmarking your application. Let's look at auto scaling. So I touched on concurrency and auto scaling earlier. Let's look at what configuration we have available here. So if I was to go on Add New and try a custom config, I can set up what the expected concurrency I think my container can handle. I can set up the minimum size and the maximum size of instances that my autoscaling should have. And then click on Add. I already am using the default config, so I won't go with that option for now. This is where you can really granularly tweak the scaling requirements of your application. Let's go into health checks. App Runner out of the box gives you a load balancer that is managed by AWS. However, you can control all of the metrics that are going into that load balancer. So what do you consider a healthy timeout? How frequently should the load balancer ping the backend services to check if they're healthy? What is the healthy, unhealthy threshold that you consider is good for your service? For security, your source code or your Docker image is encrypted. It is encrypted via an AWS managed key or a customer managed key that you manage by the service called KMS, which is Key Management Service. On the networking side, you have two modes for network egress out of the service. One is the public access, which is where every request that is going out to the public internet, or you can select custom VPC. If you pick the VPC routing option, which in purpose of this demo I am, we'll have to create a new VPC connector. So let's say add new VPC connector. I give it a name. Select the VPC that I want and pick on the subnets that I want. For availability, we recommend at least 3 or more availability zones that map to your subnets, and then click on the security group. Since this is for outbound only, the only rules of the security group that really matter are the outbound rules of the security group. And then click on Add. There you go. It's now using a custom VPC connector. What this essentially does is it will place and provision a VPC connector in all of the subnets that I specify. What this means is that any of other resources within those subnets that I want to communicate to are now available to AWS App Runner. Over here, I can add tags to my service. So if I wanted to use tags either for cost or security or authorization purposes, I can add up to 50 tags to my service. In terms of configuration, that's about it. So let's click on next and see what our service does. And we have a review screen and create and deploy. So now the service creation is in progress. What this is doing in the background for you, we're going out to GitHub, fetching the source code for you, building that source code according to the Docker file specification that you have. Then once the source code is packaged into a Docker image, we're then deploying it onto the App Runner servers. After the deployment is complete, we will register those servers to the load balancer. That load balancer has a machine-generated URL that you can see here. However, you can customize this using your custom domain name. So once this service gets up and running, I'll be able to click on this link to view the service that we just deployed. For the purposes of demo, I have prepared a service that's already running earlier. So let's go ahead and take a look at that one. I'll go into my demo service. This is pointing to the same GitHub repository that I had shown you earlier. And once this loads up, there you go. That's the website that we just published on AWS App Runner. Now this is already tuned to continuous integration and continuous deployment, which means if I was to do another commit and another push to the GitHub repo, my CI/CD tooling would pick it up and deploy the new service automatically via blue-green safe deployments. In terms of metrics and configuration, they're all available here if you wanted to change them. And if you wanted to add a custom domain name, you can do that via this tab here. All of the logs are shown here as an event log for the live console debugging, but all the retrospective logs can be viewed by clicking on CloudWatch here. All right, that's all for the demo of the App Runner service. Let's get back into the presentation. So now that we have seen what the App Runner experience looks like, let's look at some features that our customers are really excited about. Managed deployments is a big ask that our customers have had for us for our container services such as Elastic Container Service or Fargate. And so now we have taken that heavy lifting away from them, where we've allowed automatic deploy on committing code or pushing an image. We have a Start Deployment API, which is where you put that configuration in for your service. We support blue-green deployments, which means that we provision new instances with the updated version of your Docker images and then slowly drain out the connections to your older container instances. Thus, you can do deployments with zero downtime. Also, we have rollback features. So if your new code deployment fails for some reason and we get notified by the health check that you've configured, we automatically, by the same blue-green strategy, fall back onto your older container image. Your deployments are quite safe in that manner. From an observability point of view, all of the logs and metrics that are published by our individual container images are delivered to CloudWatch. So if for debugging purposes or for retrospective production monitoring, you can look back at all of those and replay those via CloudWatch. For any of the service lifecycle events, which are the events of App Runner itself, those are published to Amazon EventBridge. You can go to Amazon EventBridge and have a look at how your deployments were done. When was a load balancer registered, etc. All of the API actions directly to the App Runner service itself are all monitored by CloudTrail. If you had a requirement for security to track and log all of the mutations to your service, that's all logged in CloudTrail. Some other exciting features that our customers have asked us for are custom domain name support. The URL that you saw where there was a machine-generated URL, instead you can attach your custom domain name and use that instead. It has managed TLS certificates for you, so no need to be worried about when you need to renew your expiring certificates. All of that is managed for you. All of the source code that you provide us and the container images that you provide us, they're encrypted. They're encrypted via AWS KMS, Key Management Service keys. You can either use your own keys or you can use AWS managed keys. We also have an added feature to pause and resume your service. So if you are an active dev and test and you don't need the service to be running 24/7 and just within business hours, this allows you to pause your service, not consuming resources and hence not costing you money. This is an exciting new feature, which is the addition of VPC networking support. A lot of customers are asking us about it. It means that, as I've covered in network egress earlier, you can securely connect to your private VPC resources and AWS APIs without reaching out to the public internet. Now let's have a detailed look at pricing and what the pricing dimensions people need to be aware of while deploying this service. Firstly, the application instance itself has a CPU and memory cost. That's according to what you configure. If you're opting for the build from source method, then there is a per minute build cost. That's based on how much time it takes us to build the Docker image. Then there is an automated deployment. If you've opted for automated deployments, there's a $1 per service per month cost. For data transfer out, either via the public internet egress method or the VPC egress method, standard AWS data transfer costs apply. I have linked detailed pricing examples via the link in the next slide. So to summarize, what have we covered today? We've covered AWS App Runner, which is a managed serverless container service that takes away all of the heavy lifting of running containers in production. We've seen how useful and easy it is to connect directly your source code repo. It pulls out that code for you, builds it, and deploys it for you automatically. We've seen how this can make pricing and networking very simple. There's really 2 to 3 utilization-based pricing metrics, which we use to cost the service. So if you have a good idea of how many concurrent requests your container can handle locally and in the cloud, you've done some benchmarking locally, then you can create quite accurate picture of how much the service is going to cost you in the cloud. As next steps, check out the link on the screen. It has a sample workshop, sample pricing examples, and that you can get started with AWS App Runner immediately. That's all from me today. Thank you for attending my talk on how to rapidly build and deploy apps using AWS App Runner. Come join us at the Startup Loft by scanning this link. You're welcome to upskill yourself via AWS Skill Builder and AWS training and certification links shown on the screen as well. Thank you for attending my session. Please give us some feedback to tell us how you liked this session on AWS App Runner and where we can improve. Thank you.